Today's video isn't going to introduce you to any new instructions, but I do want to have you do some more practice about working with our bit level instructions. So basically our contacts and coils, the ones we've been describing as examine if open, examine if closed. Connected Components Workbench also describes those as direct or reverse contacts. And then also our output instructions, the output energize, the latch, unlatch, set, reset, are the different names for them. So let's go ahead and start up Connected Components Workbench, and we're going to, just for practice, start from scratch without a template file. So I'll go to New. I'll just, default name is fine. You'll probably want to save it as something specific for you. You have a location where you're keeping your files, but I won't be saving this one. So go to Controllers, Micro 810, 12QWB. If you're interested in seeing what the other options are, you can look at them. The main thing that changes in this 810 series is what power supply it requires and whether the outputs are relays, like we're using, or a DC transistor output. So QWB is the one we want, version 7, select, add it to project. Okay, I've got my controller in there now. I'm going to go ahead and say it's got an LCD in it. I'll leave the names just as default. I'll go ahead and set up my connection path while I'm here. Okay, so I'll need to add a program. So select Programs, add a ladder diagram, and I'm going to call it More Bits, because we're just going to be getting more practice using our basic Boolean bit logic instructions. Go ahead and open that up. And I want to just go over the same instructions we've talked about previously. So the most basic instruction is called the direct or examine if closed. So I'll drag one of those down there, and we'll just use one of our inputs. So let's see, input 4 I think is my green push button, and I will go add in my, just to remind you, this is where we add in our aliases, or we would call them tags. So input 0 is red push button, input 1 is the toggle, input 4 is green push button, input 5 is black push button, output 0 is green lamp, output 1 orange lamp, and output 2 is red lamp. Okay, it's just nice to have those in there so it's clear when I'm using them. So I'll go back to my program, where is it, More Bits, there we go. And you can see it didn't update it. Let's see if I select it, one of the other ones, if it updates. Yep, so if I go back to 4 now, it updated for my green push button. Okay, so let's talk a little bit more, just reviewing what we did on Wednesday again, what this instruction means. So there are two things you need to understand to make sure you're using these input style contacts correctly. The first is that there is a hardware true or untrue. So if there is a voltage present on input 4, then the input, we would say, is energized. The input would be a 1. If we came back and looked at that input while it was connected, it would have a check mark under that physical that we looked at before. Then there's a second level of truth then, is whether the instruction that we put here is true based on that hardware state. So when I put in this what looks like a normally open contact. Again, they call it direct or examine if closed. That means this instruction will be true when the input is energized. So let me drag another rung down below and use the opposite. So you can see this contact is called a reverse or examine if open. So I'm going to drag it down and I'm going to address it to the same push button, the green push button. So now, hopefully it's clear that on both of these rungs, they're both looking at the same input. When that input has a voltage present on its terminal, the hardware for digital input 4 will be true. In that case, this examine if closed instruction will be true. At that same moment, down here, we have the examine if open or reversed contact. This one will not be true when there's energy present on the terminal. And so just on the opposite side then, when there is no energy on input 4, this instruction, the reverse instruction, will be logically true. And this one on rung 1, the examine if closed, will be a logic false. So I can, so that's hopefully that's really starting to sink in. We've been talking about those ones for a few days now. Looking on the output side, we have a number of different options. We have the direct coil, which is, you can think of as the output version of the direct contact. So what it says is that when, let's put the green lamp on it. What it says is that when the rung leading up to this instruction is true, then it will make this output energized. As opposed to the reverse coil, let's put that down on rung 2. And let's put that on the orange lamp. So this is a reverse output, and just like the reverse or examine if open contact, it's the opposite of the one above. So in this case, when the rung in front of it, the rung leading up to the reverse output, when it's false, this instruction will be true. So we have used the opposite on the input and the opposite on the output. So in this case, each lamp will be on when the push button is pressed. On rung 1, it'll be on because when the push button is pressed, digital input 4 will be true, and the type of instruction we have looking at digital input 4 says, I'll be true if my input is true. So that'll bring truth across this column here, and then we said a direct output, if the rung leading up to it is logically true, then its output will be on. So that's pretty intuitive how that works. It's just how you would expect it looking at a discrete circuit. The next one is the one that kind of twists our way of thinking a little bit. We're using the same push button, so we know that when rung 1's instruction is true, rung 2's instruction will be false. So if it's false coming up here, we're using a reverse output that says if the ladder leading up to it is false, that's when I'm going to energize my output. Or if the rung leading up to it is logically true, then its output would be off. So kind of basically trying to point out each of these rungs will do the exact same thing, just one is using direct logic and the other is using reverse logic. So this is kind of like the question one of you asked the other day in class, does it matter if my hardware is a normally open or normally closed push button? It clearly doesn't, because you can completely reverse the behavior of any input depending on which type of contact you look at. And the same is true as the output. You can reverse any logic coming into it by using a reverse output instead of a direct. So let's go ahead and download this to our PLC. Okay, we're online with it, and before I push any buttons, let's just look at our logic. So looking at the PLC, we can see that input 4 on the screen here is not energized, and that's also clear to us by looking at the color of the label IOEMDIO4. It's blue or false. So the input is false at the hardware level, and since we're using the type of instruction that says this is examine if true or examine if closed, basically saying I will only be true logically if my hardware is on, that's not happening. So we have a false condition here, so leading into our direct output there's no logic high, so it's off. Looking at the next rung, we're looking at the same hardware, but we're using the opposite type of instruction. So we say, in this case, our instruction will be true when the input is off. Okay, so we have a true rung leading across to our output, but in this case we're using a reverse output that says if the rung leading up to me is true, then my output will be off. So now I'll push the green push button, and both the green and orange lamps came on because we've just inverted that hardware. Okay, that's another quick overview of the direct and reverse inputs. Okay, so next I want to talk about using bits that aren't hardware tied to an input or an output. So those are our user-defined variables. And before I do that, I want to give myself some more input and outputs to play with. So I'm going to enable my LCD display so that I can use the push buttons on that. So hopefully you remember from yesterday or the day before, anytime I'm going to use an LCD display, I have to put in the LCD instruction just to enable it. All this does is basically say I have an LCD and I'm going to use it, and I'm not planning on using the display right now, so I'm just going to put in 2 single quotes to blank out the display on each line. Okay, so that's now enabled the display, but what I really wanted to do is get to where I can use the buttons on it for inputs. So I'm going to add another instruction, and if you remember, that one was called key read. Okay, and as you remember, I could assign variables to all these, but I can also just use the ones that automatically created, and that's what I'm going to do. Okay, so I am going to insert some rungs above that. So let's practice setting bits that aren't actually inputs or outputs. We're just going to use them to indicate, say, status of a machine. So I'm going to create those variables. I could make them either local variables or global, and I'm just going to go ahead and make them global for this case. Remember to create a new variable. You open the variables file, scroll to the bottom where there's the one with the star, and then you can just type a name. So I will say my first bit is going to be called phase 1, and I would need to set what data type it is, but I said we're doing Booleans. We're just looking at single bits for status, so I will leave that as phase 1. Then I'll create another one that's phase 2, and another one that's phase 3. Okay, so we have 3 phases that we're going to use now. So let's go back to my program. I'm going to clear out what I have here, and let's as part of doing this where we're using user-defined variables, let's also start using that set and reset bit. So remember, the set bit is basically like a CLIN circuit without having to do the additional branch with contacts in it. So it's also called a latch, is a good way to think of it. If you use it to control any bit, once it sets that bit true, it will remain true until you use a reset bit to set it to false again. So let's say our green push button is going to be our start button. So I'll say green push button. And when I push that green push button, I want to set. And now instead of turning on a lamp or something, I am going to set my phase 1 bit. So that'll start my sequence basically. And then let's say after I want to use my black push button to go into phase 2. So let's set that black push button. Okay, and I'm going to go ahead and put set for it for phase 2. So let's just review what those two rungs will do. Push the green push button, that's starting phase 1. Then the black push button would be moving into phase 2. But let's start thinking about how would this work in reality. Would we want somebody to be able to push the black push button and immediately go into phase 2, skipping phase 1? Probably not. So in that case, I'm going to put in series with the black push button, I'm going to put a phase 1 bit. So you can see here I'm using it logically. So this rung can only become true if I'm in phase 1. So I hope that makes sense. If I didn't have that in there, somebody could have just pushed the black push button and skipped straight to phase 2. But now you have to be in phase 1 and push black push button to get into phase 2. Okay, so that makes sense. Let's think about one other thing. If I've pushed the black push button and I'm going into phase 2 from phase 1, probably at that same time I want to reset phase 1, right? I want to say, okay, I'm done with phase 1. So that means at the same time that I enter phase 2, so I'm setting phase 2, I'm going to use the reset to set phase 1 back to 0. Okay, let's just walk through those two rungs again. Start up the program, none of these outputs will be energized. I hit the green push button, that will set the user-defined bit that I created, phase 1, to be a 1. And it'll just sit there in phase 1 until I come along and press the black push button. And when I press the black push button and I'm already in phase 1, then it's going to set the phase 2 bit and reset the phase 1 bit. Okay, I hope that's making sense. To give me some ability to see what's going on now, I'm going to add some more instructions that control actual outputs depending on what phase I'm in. So on rung 3 here, let's use a direct contact and let's look at phase 1. So let's say that in phase 1 I want the green light to be on. That'll show me that I'm in phase 1. I'm going to use the direct coil output because I only want the light to be on while I'm in phase 1. I don't want it to stay on when I get into phase 2. Okay, so that green lamp will indicate phase 1. I'm going to add another rung and I'm going to have phase 2, my phase 2 status bit, as the input to it. So when I'm in phase 2, so when this bit is high, this will become true, and I'm going to have the orange lamp on. Okay, so when I first start, just green lamp will be on. Then when I hit the black push button, the green lamp will turn off and the orange lamp will turn on. And let's stop there for now and download it and see if it behaves as we expect. Okay, so you can see all our rungs are false at the moment. So I'm going to hit the green push button, and you can see on the PLC trainer the green lamp came on, and you can see that everywhere that phase 1 bit, my status bit, is referenced, the instruction is orange, because as soon as I hit that green push button, it set phase 1 to be true. So that phase 1 bit is sealed in now. It's not going to go to a 0 until I do the reset here. So to reset it, I hit the black push button, and now the orange lamp is energized and I'm in phase 2. And if you look, the phase 1 bit is now 0 or a false because we reset it here. Okay, so I mean that's really basic of a phase. One thing to note that I didn't put in there is I didn't put anything that protects me from backtracking into phase 1 while I'm in phase 2. If you look at it, there's nothing that says I couldn't hit the phase 1 green button again right now and be in both phase 1 and phase 2. So these are just the kind of things that you'll need to start thinking about and playing with as you're practicing. So I'm going to disconnect, and I'm going to add logic that prevents me from going back into phase 1. So I'm going to pause for a minute, and I want you to think about what would I add to make it so that I can't energize phase 1 while phase 2 is true. So there's a number of ways I could do it. What I think is probably makes the most sense would be to put a reverse contact in line with that, looking at phase 2. So if you think that through now, when I'm in phase 2, so basically once I've set the phase 2 bit, this will open and it will no longer allow me to energize phase 1 until I'm out of phase 2. Okay, we were going to, let's see, what we were also going to add a third phase, right? So let's see, what input could we use to do the third phase? So we added the LCDs, so we can add a rung here, and I'm going to use a direct contact again, and I'm going to look at, this time it'll be a local variable, because it's that key read. And remember, I'm going to cancel that and go back and do it again so that you can see what happened there. It's not showing up because they're filtered right now. So I'm going to clear my filter so I see the key read. And I'm going to look for, let's use the up key. So that would be this one right here. Okay, so that's good. Hopefully you're thinking things like this, adding a set to phase 3, and we probably don't, we want to add some things in there that keep me from energizing it if I'm in phase 1 or 2, right? So let's add those in there. Say a not for phase 1. So if I'm in phase 1, I can't skip to phase 3. If I'm in phase 2, it's okay to go to phase 3, so I wouldn't put that one in there. But now in phase 2, the set rungs for phases 1 and 2, I probably should add in here that I want to use a not for phase 3, so that I can't start phase 1 or phase 2 while I'm in phase 3. Okay, and I need to add a branch down here on my output that says, okay, if I'm going into phase 3, that means I need to reset or clear phase 2. Okay, let's take a look at what we have now. My first rung, I can hit the green push button to start phase 1 as long as I'm not already in phase 2 or phase 3. That looks good. Then to go into phase 2, I hit my black push button, and it'll work as long as I'm currently in phase 1 and not in phase 3. And if that's all true, then I'll set the phase 2 bit, set the phase 1 bit. Okay, so now I'm going to have phase 2 is true. Now when I want to go into phase 3, let's take a look at that. I think I'm going to need to add something here. I have an up key press, and probably just like I did up here, I want to add in a normally open for, or a examine if closed, for phase 2, so that this rung will only work to get into phase 3 if I'm in phase 2, not in phase 1. And so that's a little duplicative there too, right? Really, I could put just the I have to be in phase 2, not needing to say I can't be in phase 1, because I've up on this rung made sure that I can't get into phase 2 while phase 1 is energized. But it's not going to hurt anything having it in there either. Okay, and then to get for phase 3, let us say we want, oops, I didn't want to put it there. I want to move it down so they're in order. Okay, and then we'll use our phase 3 bit again to control, let's see, we got the red lamp left. Okay, and one thing to note here is I am not using set or reset on these green and orange and red lamps. I'm using the direct contacts, and I'm controlling them using set. The bits are being set and reset. Does that make sense? So they're staying on even after I hit the push button because the phase bit is being latched or sealed in, if you want to say it that way. Okay, so I think now we have logic that'll help us move through from phase 1 to 3, but we don't have any way to get out of the phases when we're done and start over. So let's add one more rung. We'll do it up here, and let's use the escape key. So it's local variables, clear the filter, and the escape key or cancel key is, I want to do the one that I don't have to hold for 2 seconds, so that is this CKY. We'll use it, and when I have that, I'm going to use it to reset the phase 3 bit. I'm also going to use it, I'm just going to put in parallel to reset phase 2 and to reset, oops, didn't land it. Come on. Reset phase 1 as well. So that way I can use the escape key to start over no matter what phase I'm in. Hopefully that all makes sense. I'll just scroll through the program there for a minute. You can see it. So rung 1 is the logic that gets us into phase 1. Rung 2 says, okay, if I'm in phase 1 and I'm not in phase 3 and I hit the black push button, I'll start phase 2 and I'll undo the bit that was keeping track of phase 1. The next rung just moves on one more level. If I hit the up key while I'm in phase 2 and I'm not in phase 1, then start the phase 3 bit and keep it high until I do something else and reset the phase 2 bit. And then this one, our escape key, at any point if we hit it, it will clear all the phases, so we'll just be back kind of in our waiting state. And then I have 3 rungs that are controlling the 3 lamps depending on what phase I'm in. So let's download that. Okay, we scroll to the top, looking at the first rung, our bits that say am I in phase 2 or phase 3, those bits are not true, so the instructions, the reverse instructions, are true. So all we're waiting for this first rung to get true is a green push button. So I'll press the green push button. That energized gave me a true across, and it set the phase 1. And so down here looking, you can see we're in the green lamp. So let's try skipping ahead to phase 3. So that would mean pressing the up key. And if you're looking at rung 3 there, you'll see that the up key is pressed, but I haven't moved into phase 3 because the phase 2 bit on rung 3 is not true yet. So that's good logic I have in there. It keeps me from skipping to phase 3 before I've done phase 2. Okay, but looking at rung 2, I am only waiting for the black push button press to become true before I can get into phase 2. So we'll hit the black push button, and you can see orange lamp is now on, and the phase 2 bit is true. So now, looking down at rung 3, all it's waiting for is the up key, and we're into phase 3. So now let's check and see if our reset function works. So we're going to hit escape, and you can see it reset my phases. I'm now ready to hit the green again. Before I hit the green, let's try hitting up. It's not letting me skip to phase 3. I'm going to try hitting the black. It's not letting me skip to phase 2. So now we've got logic in there that basically steps us through a 3-phase program based on input. So hit the green push button, phase 1. Black takes us to phase 2. If I'm in phase 2 and hit the escape key, I go back to where I can start at phase 1 again. Okay, that's I think a fairly extensive review of our direct contact, which means it will be logically true if its input is energized or the variable it's looking at is a 1. The reverse contact, that is logically true if its input or the bit it's looking at is a 0. We're also using the direct output, which means the output will be true if the rung leading up to it is true, but it will only be on while that rung remains true. So it's not latching, it's just following the status of its rung. We're using the set coil, which is similar in that it becomes true when its rung leading up to it is true, but it's different than the direct in that it stays set until you address the same bit with a reset coil. So set and reset are paired, they work together to latch and unlatch a bit, either a hardware address or a user-defined bit like we created here. Okay, let's pause there. So one other just programming tip that I've kind of demonstrated here as we've worked through this example is I didn't start from the very beginning and write all 9 rungs of this program with all 3 to 4 inputs per line. I started with a couple rungs, made sure they were working. I then added a little bit more functionality, verified that it worked, and continued to build on that. It's especially when you're learning, that's a far more reliable way to build a program and less frustrating because you're only troubleshooting your most recent changes that way. So, once you've been used to programming, like in my case, I could just go in and I probably could have done this in one shot, all these rungs, all these instructions, because it's a pretty simple program. But if I had messed up, used a direct instead of a reverse here, it's just more time consuming to have completely new code to troubleshoot from. So I encourage you to work in bite-sized chunks. Test one rung, make sure it behaves as you want. Then build the next rung, add a branch to it, add some more logic that controls leading into your outputs, that kind of thing. So just break it down into pieces and test each piece as you build. I wanted to add one more thing I thought of as I was finishing up this exercise. You'll notice here I'm addressing each output, the hardware address, only at one point in the program. Let's say if instead of having only the green lamp on for phase 1 and only the orange for phase 2, let's say I wanted them to build on each other. So I wanted the green lamp on in phase 1 and the orange lamp on and the green lamp on in phase 2, and then all three lamps on in phase 3. The first instinct some students have is to do something like this. Add a branch here and add the green lamp to this rung too. And depending on how you do it, that might work, but this is a good way to get into trouble, to address the actual hardware output in multiple places. So if you can avoid it, I would encourage you to do so, and you almost always can avoid it. So hopefully you can see that I can create the same function, having both the orange lamp and green lamp on, without addressing the green lamp twice. By, instead of doubling up on the output, I can double up on the input. So I say I want the green lamp on in all three phases. And I want the orange lamp on in phase 2 and in phase 3. And then the red lamp only comes on in phase 3. So you can see I'm still only addressing each of those outputs in one location, but they're going to be on in multiple phases. So let's just download that. Okay, let's see what happens now. Phase 1, phase 2, phase 3. And the lamps are progressively turning on rather than individually. And then my escape sets me back. Just a reminder, I can't skip to phase 3, can't skip to phase 2. I have to go in order. Phase 1, 2, 3. So you're already learning how to control a basic machine that works in several phases. And in this most recent step, we've learned how to turn on not just an individual output for each phase, but to control multiple outputs depending on what we want to have happen, and to do it in a way where each output's only addressed once, ideally. Okay, I think that's enough review. I'll give you another assignment today that goes over using basic bit instructions. I would encourage you to read the user manual. Actually, not encourage. I'm going to put it as an assignment to read the user manual section that goes over these instructions. So I think I have that open here. I'll put it in the assignment, but basically in the reference manual. So this is what I had you download during that first week. If you right near the start under ladder diagram, language and elements. So let's say starting this section here, it's going to talk about how the different rungs and whatnot work. This is a great introduction here. Let me go back to the table of contents. So basically I will have you read, I'll put it in the assignment, but I would encourage you to read from basically page 17 through to page 63. And by read, I mean take a look at the instructions. You're not memorizing it. Like let's just jump to one of these pages. So set coil, we've been using those a lot. So that's starting here on page 48. I think you should read, this paragraph or so describing how the set coil works. And then there's just some examples to look at. Reset is next. So it's not a lot of reading. It's more browsing the types of instructions, reading their description of how they work. Just another way they may explain it more clearly than I have for you. But take a look at that reference, or do a similar thing by hitting F1 for those instructions as well. Okay, that's it for today. Thank you.